gonna sort them out now. Let me just send you the link again for YouTube.
Okay.
I'm sending it on WhatsApp.
Okay.
Sent.
Let me just do my whole thing. Okay, so are we on?
Awesome. Okay. We're gonna start with your issues. Let's resolve them.
Okay. Okay. So the first one, number A, 1A.
The first one.
Yes. I found is there a possibility to have two common factors?
Let's remember. Question 2A. Or you are looking 1A.
Where it says,
Remember, Ahisha, you can only find common factors if you are adding or subtracting. Remember that?
okay.
On this
Oh,
one,
so this one. Oh,
it didn't require common factors. So the only way you can factorize is when there is addition and subtraction. You cannot factorize anything that does not have the addition or the subtraction.
Okay.
Right?
Yes, sir.
Yeah, so it's important for you to understand that. So the first one, if you look at it, we had it as 3 to the power x plus 3 multiplied by 12 to the power x minus 3 all over 2 to the power 2x minus 6 multiplied by 9x, right? Which means the first thing that you need to do, what's the first thing you needed to do there?
Prime basis. Prime basis.
Exactly. So this was going to be 3 to the power x plus 3 multiplied by 2 to the power 2 multiplied by 3. Am I right?
Yes. Yes.
All over 2 to the power 2x minus 6 multiplied by 3 to the power 2 to the power x. And then from there, you are going to, after finding the prime basis, you need to apply the rule. when you raise a power to a power, right? You multiply,
Yes.
you multiply the powers. So this is now going to be 2x minus 6 multiplied by 3 to the power 2x. So before you get anywhere else, these have to be simplified. I said before you divide, the numerators have to be simplified, all of them, right? I can't see Ahisha. I can only see your sister there. Konja, what's your name? Yes.
Ash.
Ash. Okay. I can only see. Now I can see the two of you. So now let sorry. Let's look into this. Look at that and that. That can be added together, right? Those are the same bases. So we're going to have 3 to the power 2x because 3 minus 3 will give us 0. Right?
Yes.
And then we are going to get the other one as 2 to the power 2x minus 6 all over 2 to the power 2x minus 6 multiplied by 3 to the power 2x. And the answer here is 1. Are you following?
Yeah.
Yes.
Yes.
So if there is no addition and there's no subtraction, you cannot look for a common factor. You can only look for a common factor where there is addition or subtraction. Look at this. If you happen to have 3x squared plus x minus 2, because of this addition and subtraction, then you can factorize. Are you following? You cannot factorize. You cannot factorize if there is no addition or subtraction all the time. Are we clear?
Yes, sir. I didn't know that part. I was mixing up my.
Oh, you were mixing
So
it up.
for this one, I know how to do it now, but I was doing it the other way, where you break it down. So if you say 3 to the power x plus 3. So I was doing it to break it down, and we say 3 to the power of x times 3 to the power of 3 that way.
Look at this. Remember I said mathematics revolves around 4 principles. The principle of addition, the principle of subtraction, multiplication, and division. Right? So, and I said when we talk of exponents, under exponents, we need to know how to add them. We need to know how to subtract them. We need to know how to multiply them, and we also need to know how to divide them. So the other lesson focused mainly, at the first lesson of exponents, we focused mainly on division and multiplication of exponents, if you have noticed. And later on, we moved to the addition and subtraction of exponents because the two go hand in hand. The inverse of addition is subtraction, and the inverse of division is multiplication, right? So all in all, what we've been doing was, at first, I showed you how you can divide and multiply exponents. And then we later came back and I showed you how to add and subtract exponents. And this is where the common factor now comes in, all the time. So if you are doing calculus and you see addition and subtraction, you must know that you need to factorize. Because unless there is addition or subtraction, addition or subtraction, you cannot factorize. Are we following? You see the second one? The second one, there is subtraction. Are you following?
Yes.
So,
yes, sir.
If you notice at the second one and the third one, there is also subtraction. So if there is a subtraction, it means somehow, somewhat, we need to do what? Divide. We need to find a common factor.
Yes, sir.
So this is what I want you to know. Every time when you see an addition, you must think of a common factor. Every time you see a subtraction, you must think of a common factor. Are we clear? because that's the
Yes.
only time we can do that. So let's do the second one. We have right here 3 to the power x minus 1 minus 3 to the power, it's x plus 1 minus 3 to the power x minus 1 all over 2 multiplied by 3 to the power x. Are you following? So once we have it like that, we need, because of this, what are we gonna do?
So you're gonna break it down and then find the common factor.
So every time you see that, you must think of a common factor.
Okay.
Yes. So first thing first, but the only way to get to the common factor is to break down each and every term, right?
Yes.
Which is going to be 3 to the power x multiplied by 3 minus 3 to the power x multiplied by 3 minus 1 all over 2 multiplied by 3 to the power x. Remember, you were doing this so that you can find a common factor, which means you cannot move on unless you find that common factor. Because the reason for breaking this down was what? To find a common factor. And our common factor is 3 to the power x, right?
3x.
Which is going to be 3 minus 3 minus 1 all over 3 to the power x multiplied by 2. That and that will cancel. Put it the way it is in a calculator. Thank God I have my calculator today. And when you put it the way it is in the calculator, you are going to get what?
4 over 3.
It's going to be 4 over 3. And this is how in an exam I will distribute marks. For breaking it down, I give you a mark. For finding a common factor, I give you a mark. And for actually the final answer, I'm going to give you a mark. So normally these expressions, it's... Yeah. Let's do C. So C, we have 2 to the power x minus 3 minus 3 multiplied by 2 to the power x minus 1 all over 2 to the power x minus 2. If you notice the first one, you need to find what? You need to first break it down because of this. You are breaking it down because of that. And the reason for you to break it down is to look for what? The common factor.
Common factor.
Sorry?
No, we're agreeing with you,
Yes.
sir.
So, which means the only way to do that, we are going to now break it down. 2 to the power x multiplied by 2 to the power minus 3 minus 3 multiplied by 2 to the power x multiplied by 2 to the power minus 1. That's how you broke that down, right?
Yes.
And then from there, we divide. We have 2 to the power x minus 2. But at the same time, we might as well break down the other one. Are you following? So from here, we look for our common factor, which is going to be 2 to the power x, 2 to the power minus 3 multiplied by 2 to the power minus 1, all over 2 to the power x multiplied by 2 to the power minus 1. And if you notice, that and that will cancel. And you put it the way it is in a calculator. Don't try to be a superwoman. I will say this until you get it. Right?
It's negative 11 over 2, sir.
Negative 11 over 2.
Over 2.
That's what you both got.
Yes.
Okay. I'm just checking if my calculator is working. But I got negative 3 over 4.
Huh?
I got negative 3 over 4.
Okay, wait. I'm still getting negative 11 over 2.
Let me check. Maybe my calculator is the one giving me wrong things.
Yeah, I'm also still getting negative 11 over 2. So is your calculator setting correct?
I'm still getting negative 3 over 4. Put it exactly. Put it like this. Let me try it again. I will hate calculators after today. We're not getting the same answer.
Let me try something. Oh, so
Yeah.
even if I insert brackets, or it's like still giving us 11 negative. So, do you know why you're getting negative 3 over 4?
Tell me.
Because you, instead of putting a multiplication sign, you're putting a dot, and the dot is considered as a comma on the calculator.
Oh, so you were putting a dot. Oh, was I putting a dot?
No, we're putting a mark.
Oh, yes.
You're putting a dot.
Oh, yes, I get it. I get it. My bad. So it's negative 11 over, it's a negative 11 over 2, right?
Yes.
It's negative 11 over 2. So the same way, the max will be 3. For finding the common factor, for breaking everything down, and etc. etc. Are we clear? Let's do... I'm interested in D. Did you see D? Did you get that?
Yes, I have a question on D. So they said 5 to the power of negative x equals 10. So
Yes.
that means that when you are breaking down, you should replace 5 to the power of negative x with 10. But we didn't get a negative to the power of negative x. We just got to the power of x.
Let's work it out.
Okay.
Here we have 2 to the power x minus 1 plus 2 to the power x plus 1 all over 5 multiplied by 10 to the power x, right? So first thing first, we need to break this down. It's going to be 2 to the power x multiplied by 2 to the power minus 1. Plus 2 to the power x multiplied by 2 all over 5 multiplied by 2 to the power x multiplied by 5 to the power x. Am I right?
Yeah. Yes. That's where I left off. I didn't continue from there.
Which is going to be 2 to the power x into 2 minus 1 plus 2 all over 2 to the power x multiplied by 5 multiplied by 5 to the power x, right?
Yes.
So the 2 cancel, and you are going to have this as 2 to the power negative x plus 2 over 5 multiplied by 5 to the power x, right?
Yes.
But at the same time, if it's divided by, remember, if you have 1 over 5x, is the same as 5 minus x.
Yes.
So it means then you can have this as 2 to the power negative 1 plus 2 over 5 multiplied by 5 to the power negative x. So the 2 can multiply, and then you have your 5 negative x. Then you make that 10. Is it making sense?
Yes.
Remember, guys, if you have 10 over 2 to the power x, this is the same as 10 multiplied by 2 to the power negative x.
Okay.
Yeah. It keeps saying my network is poor. I need to reconnect. Can I do that?
Yes, sir.
Yeah. Is it about my network, that sound?
So your network is fine on this side.
It's fine on this side. Okay. It's not pausing, nothing.
Nope.
Okay.
Fine.
The tricky part there was you finding out the value of how to write that 5 minus 5 to the power negative x. So as I was explaining, if you have 3 over x, this is the same as 3 multiplied by x to the power negative 1. Is it making sense? By x, this is the same as 5 multiplied by 2 to the power negative x. Are we clear? So if we have 100 over x, this is the same as 100 multiplied by x minus 1. So you need to remember that all the time. Let's do question 2.
Okay.
We have the first one, 2 to the power a plus 1 minus 2 to the power a is equal to 4. The most important part there was, I said to you, if you see that, it means you need to find what? The common factor. Are you following?
Yes. Yeah.
So to find the common factor, we're going to break this down. And our common factor is 2a, right? It's 2 to the power a, which is going to be 2 minus 1 is equal to 4. Do you see that?
Yes.
And 2 minus 1 will give us 1.
Yes.
Which means we have 2 to the power a is equal to 4. 4 can be written as an exponent, which is going to be 2 to the power a over 2 to the power 2, where a is equal to 2 because now the bases are the same. Then you equate the exponents. You got that?
Yes.
So look at this. For that, I was going to give you a mark. For finding a common factor, I was going to give you a mark. For actually getting that part right, so basically for getting this part right, it's a mark, and for the final answer, it's a mark. So these questions normally have 4 marks when they come in an exam.
Okay. So what if you for the first 2 marks, what if you already changed 4 to 2 to the power of 2?
You can do that. But remember, 4 is not an exponent per se, but you can still do that part because I said each and every term must be as a prime base, right?
Yes.
Yeah, so basically it's my bad. It was supposed to be 2 to the power 2 minus 2 to the power a is equal to 2 to the power 2 because 4 must be in its prime base. So for doing that, you're going to get a mark either way.
Okay, sir.
Yeah. Let's do the next one. So here we... Yes?
So sorry. For this next one, if you look at the questions, they have, so it'll be like 27 to the power of x to the power of 2. What's happening there?
You treat it like any other exponent.
So, but to the exponent, like it's to the power of to the power of.
Yeah.
That power.
The rules never change.
I didn't know how to do it. I got confused. I attempted, but it wasn't working out for me.
Look at it like this. Here you were going to, I get you have 27 to the power x squared plus x is equal to 3 to the power x squared multiplied by 9. The first rule is to make sure that everything is on its composite base. It's on its prime base, right?
Yes.
Which is going to be given by 3 to the power 3, and all of that to the power x squared plus x is equal to 3 to the power x squared multiplied by 3 to the power 2. Are you still following?
Yes.
Therefore, this is going to be 3 to the power 3x squared plus 3x is equal to 3 to the power x squared plus 2. Are you still following?
Yes.
And now that the bases are the same, you are going to equate the exponents. So now this is now going to be 3x squared plus 3x is equal to x squared plus 2. Are you following?
Yes.
And now that is a quadratic solution because the highest degree polynomial is 2. Do you see that? So everything must be on one side. And when everything goes to one side, we are going to have this as 2x squared plus 3x minus 2 is equal to 0. Because when we transpose this to the other side, it's becoming a negative, right? And then when we transpose the 2 to the other side, it also becomes a negative. Are you following? So now you are going to factorize. When you factorize, I will suggest you use the other method, the FOIL method. So we get here minus 4. When we multiply that and that, we're going to get minus 4. And the factors of 4 is 1 and 4 and 2 and 2. The one that will give us, it's minus and 3. So we have minus x plus 4x, which is going to be plus 2 minus 1. So that's how it has been factorized. You still remember the FOIL method to factorize?
Yes, sir.
Yeah.
Yes, sir.
And then now we are going to get this as x is equal to 1 over 2 or x is equal to minus 2.
Okay.
So the rules never change because you are looking at something unfamiliar. They remain the same throughout.
Okay.
Yeah. Can we do another example? The next one.
Yes.
I know that this might have given you a challenge.
Yes.
It did, right?
Yes, sir.
It needed you to think, to utilize the exponential rules. Remember, if the exponent is the same, this can be written as 2 over 4 to the power x. Am I right? Is equal to 1.
Yes.
You still remember these rules?
Yes.
And anything to the power 0 is 1, right?
Yes.
So in this case, it means we are going to write this as 2 over 4 to the power x is equal to 2 over 4 to the power 0.
Sir, why did you put 2 over 4 to the power 0?
Because anything to the power 0 is 1. And in exponents, we just have to get the basis of the exponents to be the same.
Okay.
So from here, since the bases are the same, we can come and say x is equal to 0. Do you see that?
Yeah.
So let me explain this again.
Can I tell you what I did?
Show me. Did you get 0?
No, I didn't get 0. This is what wrong one. This is what I did.
I can't see all of it. Take the camera back a bit. up, up, up. Okay, I see what you did. I see what you did. Okay. Look at this. Look at this. It's paramount to understand the tricky part. I can't see you anymore. It's very important at times to also understand what you to also understand what you're doing.
Okay.
For instance, you have 2 to the power x. 2 to the power x over 4 to the power x. There is a rule that speaks to that. Right?
Yes.
So you need to apply that rule first. Before you can change anything to the prime base or whatsoever, apply that rule first. Because even if you were to work that out, what you did, you were supposed to have 2 to the power x over 2 to the power 2 to the power x.
Yes.
Which can also lead us to 2 over 2 to the power 2 all to the power x.
Oh, it's the same thing.
It's the same thing. So to save yourself some time, this is a special kind of a thing. They hardly ask these questions. And if they ask you this question, they just want to trick you. You just have to apply, because look at this. It's 2 to the power x over 4 to the power x is equal to 1. And you need to know that in exponents, there are 2 rules that are playing part here. For you to get 1 in exponents, it's when something is to the power 0. Because according to exponents, we are told anything to the power 0 is 1, right?
Yes.
So you need to know that whenever you work this out, it must get you something to the power 0. So this is now going to be 2 to the power 4 to the power x is equal to 1. This is the only time where you are going to change this to be that base, because now you are switching. Are you following? So this is now going to be 2 to the power 4 to the power x is equal to 2 to the power 4 all to the power 0. Because now the bases are the same, but you never change the expression. You just rewrote it in exponential form. So now that the bases are the same, you can then equate the exponents.
Oh.
So the
So whenever there's a 1, we just make the bases the same.
Yes. So sometimes they can give you something like this. Are you there? So
Yes.
sometimes they can give you something like this. 8 to the power x to the power x is equal to 1. So you need to apply that rule first. This is the same as 8 over 5 to the power x is equal to 1. But now, because the basis, when we solve exponents, we need to make sure that the basis or the exponents are the same. Okay?
Yes.
So look at our base there. It's 8 over 5. So we can write this as 8 over 5 to the power x is equal to 8 over 5 to the power 0. And in this case, x is equal to 0. When they give you these questions, you're going to get an answer that is x to the power 0. But the examiner is not interested in the answer. The examiner will be interested in how you're going to get the 0.
So will x always be equal to 0 in this kind of question?
In this kind of a thing. Even if you have 2 to the power x over 3 to the power x is equal to 1. The answer is obviously going to be 0. But that you know. But at the same time, as an examiner, I'm not interested in the answer. I'm interested on your knowledge about exponents.
Okay.
So this is the same. It's going to be 2 over 3 to the power x is equal to 1, which is going to be 2 over 3 to the power x is equal to 2 over 3 to the power 0. Because now the bases are the same, you can simply say x is equal to 0.
Okay.
Yeah. So I knew that was going to give you a bit of running around. But as an examiner, I was not interested in the answer. I was interested in your knowledge of exponents. Let's do D. Aisha, do you see how these things do not matter? Even if it was to an exponent of an exponent of an exponent, you're still going to apply the exponential rules. So
Yes, sir.
this is going to be 5 to the power x squared plus x is equal to 25. So the first thing we're going to make sure that the composite bases become prime bases, right?
Yes.
Which is going to be 5 to the power x squared plus x is equal to 5 to the power 2. And now that the bases are the same, we can now equate the exponent, which is going to be
The exponent.
x squared plus x is equal to 2. And if you notice, you already have a quadratic equation right there. Do you see that?
Yes.
So this is now going to be x squared plus x minus 2 is equal to 0, which is going to be x plus 2 or x minus 1 is equal to 0, and x is equal to minus 2 or x is equal to 1. And that way that's done. So you need to, yes, you want to ask something, Ash?
Before you made a quadratic equation, I just added the exponents and gave me x to the power of 3, and then I solved it from there.
You see, you added. There is no way you can add the 2.
Oh, because it's an addition. Oh, oopsie. Never mind. Whoops. It's an addition. No. It's 2 different terms. Yes, I know, but it's also addition. It's not multiplication where you can add the exponents.
Exactly. Remember, there are 4 rules to exponents. Each and every topic. It's either you are going to add or subtract or divide or multiply. So, look, when you deal with exponents and there is an addition, anything that have an addition between the terms, right? If those terms are not like terms, you are going to factorize. But it's different if you have 2x plus 3x. Because these are like terms, they can be added. Okay? But if they are not like terms, you are bound to factorize. Like what we got here, you have x squared plus x minus 2 is equal to 0. That's completely different terms. They are not like terms. And because of these signs, you have to factorize. Are you following? But if it was x squared multiplied by x multiplied by minus 2, you didn't have to worry about factorization. You were just going to multiply everything. Are you following? So every time when you have an addition of different terms, you will be required to factorize. For instance, if you have 3x plus 6, that cannot be added together. But because of that sign, we will be required to look for factors of that expression. But if it was 3x multiplied by 6, this is going to be 18x. There's no factorization there. So the only time you can factorize in mathematics, it's when you have different terms in one expression divided by addition and subtraction between the two. Are we clear? So if the terms are unlike terms and there is addition in between them, you are bound to factorize. And if it cannot be factorized, you are bound to complete a square or to use a quadratic formula. Are you following?
Okay.
Yes.
Yes, sir.
Yeah. Can we do the last one?
Yes.
Do we have to do that or it's fine?
So I got 0.
You got 0. Let's see if your 0 is correct. You have 27 to the power 2 over 3 multiplied by 81 to the power minus 1 over 2 is equal to 9 over x. Aisha? It doesn't matter whether it's x squared or a fraction or whatsoever. The rules remain the same. It does not matter how the question comes. It must not confuse you. You stick to the rules, right?
Yes,
The
sir.
rules remain the same. And in this case, you have to do the composite basis. Oh, you change the composite basis to prime basis.
Yes.
And then from after changing that, you are going to do that thing that if you raise a power to a power, you multiply the powers. So 3 multiplied by 2 over 3, you're going to get 2, right? Am I right? So this is going to be 3 to the power 2 multiplied by, and the other one will be 4.
It's negative 2.
It's negative 2. 3 to the power negative 2 is equal to 3 to the power 2x. And this, when you multiply powers with the same base, you add the exponent, it's going to give us 3 to the power 0 is equal to 3 to the power 2x. And now that the bases are the same, you equate the exponent, and 0 is equal to x, or x is equal to 0. So your 0 was correct.
Yay.
Aisha, you look lost.
No, I got it. So,
Yes?
where was I? If you didn't convert if you left the 9x the same, it still gives you the same answer.
But you can't leave it the same.
You have to convert it.
Remember the first thing that you do when you have an exponential expression is to make sure that all the composite bases are changed to prime bases. So you cannot have 9 to the power x. You cannot. So the first step is that before you apply any rule, you need to make sure that the composite bases are on their prime basis. And once you get that, you are fine.
Okay.
And I want you to remember something. You see, when I emphasize something all the time, it's because I have marked a lot of papers. I have seen learners fail. I have seen learners excel. I have produced distinction in my teaching career, a lot of them. And many fail because they cannot even hear when the teacher is explaining. When I emphasize it, it's important. When I say it every time, it is important. That it's that thing. If you do not change this to its composite basis, it's going to make you or break you. It's going to cost you marks. That's why I always say before you do anything, you need to make sure that the prime bases are on their composite basis. That's the most important part.
Yeah.
Yes. Whenever you're dealing with expression, it does not matter whether you are adding, dividing, subtracting, whatsoever. First thing first, you check, do I have a composite base here? If yes, you change it to a prime base all the time. From there, it will be easier for you to apply all of these things. Remember, exponents are a category of two things. If you have 2 to the power x, you have the exponent there and you have the base there. Do you see that? So to multiply or to add or to divide, you need to make sure that either the exponents are the same or either the bases are the same. So the only way you can get quickly to the basis or the same basis or the same exponent is to make sure that the bases are that the composite bases are changed to prime bases every time. If you notice, if we were to go down, even here, do you see you got quickly to the answer because you changed the prime base to the composite base?
Yes.
There was a time where I forgot something, and Ash, you told me.
The last lesson.
I mean, like today here, I did not change that to a composite base, and that can be confusing sometimes. I didn't change 4 to a prime base.
Yeah.
Yes, are you following? So every time when you deal with all of this exponents, it is important for you to convert. It is important. I'm going to say this again. First, change each and check if you have composite bases. If yes, convert them to prime bases. It will be easier for you to get to the answer quickly. Are we clear?
Okay.
Now, guys, we have done everything possible that the examiner can throw to you, because if you are going to do mathematics, you need to know how to add fractions, you need to know how to add exponents, and you need to know how to add variables. Once you do that, you will be able to go far. You do know how to add fractions, right?
Yes. I think you showed us. You showed us.
I showed you. Let's say we have the following, guys. 2 over x squared plus x minus 2 plus 3 over x squared plus x, let me say 2x minus 3. Can we add that?
So I think you need the same denominator.
You need the same denominator, of course, yes. Because you cannot add fractions if you don't have the same denominator.
Yes.
So which means you got that right. You need to find the lowest common denominator first. But at the same time, look at this. This and that. It will be hard for you to get the common denominator unless you factorize. Do you see that?
Yes.
So I'm going to give you marks to factorize that. But the most important thing, you know that if I'm going to add the fractions, I need the lowest common denominator. I need the same denominator. Are we following? So that's very good. I'm glad you got that quick. You don't have to add that now. Let's move on. I was just doing a recap, if you still understand our previous lessons. Are we clear? Because from where we are,
Yes.
I can simply produce a test out of 70 from everything we have done. I can produce a test out of 70. We have done a lot already. But I want us to do...
Yes, we have.
I want us to actually go back and do simultaneous equation. Or before that, or maybe we do the nature of roots. We're going to do simultaneous equation, and then if time permits us, we're going to do the nature of roots. Are we clear? Do not be... Or let's start with the nature of roots before we do simultaneous equation. Yeah, let's start with the nature of roots. Guys, when we deal with the nature of roots, the roots is the answer you get when you do two things. Remember, numbers can either be real or non-real, right?
Yes.
They can either be rational or irrational. And they can either be equal or unequal. So, when we investigate the nature of roots of a number, we need to understand all these things. Let's say we have the number 2. Right?
Mm-hmm. Yes.
2 is a real number, right? Do you know the difference between real and non-real numbers?
Isn't real like your multiples?
No. It's a number that exists. If something is non-real, it does not exist. Something that's undefined. It has no meaning.
Undefined, yes.
Yeah.
Undefined.
So something that is non-real, it does not exist. It's like, how can I put this? I don't know. I don't want to have a debate. I don't want to push my philosophies now.
So we get what you're saying, sir.
Yeah. So many people will tell you that something that cannot be defined. So basically, something that cannot be defined is not real. Just like many people cannot define love. Many people can define love. And they say that thing exists. So if you cannot define it, it does not exist to you. But if you can define it, then it exists. Because if you cannot define it, it means it does not have a meaning to you. And why must you do a meaningless thing? So all of us have our own philosophies about love that we want people to actually be confined to it. And if someone say they love you, you expect your philosophies to come true from that. Are you following? And sometimes we don't give room for such philosophies. So we have real and non-real numbers. So 2 is a real number. But 2 over 0, it's a non-real number. Even if the calculator does not recognize that, it will give you an error. Are you following? But at the same time, it's 2 rational. Do you know the difference between rational and irrational numbers? Okay, it's fine. If, let's say we have 2 and 3, is 2 and 3 real numbers?
Yes.
Are they equal?
No.
Are they rational or irrational? So a rational number is anything that can be written as a fraction. It's a over b, and b not equal to 0. So basically 2 can be written as 2 over 1, and that makes it a rational number. And 3 can be written as 3 over 1, and that makes it a rational number. But irrational numbers are those numbers, I hope I explained this perfectly. Irrational numbers are those numbers that have a lot. For instance, a pi. If you can put a pi in your calculator, you are going to get a decimal with a lot of recurring numbers, right? So any number that gives you something like that. For instance, 2,313 469766021. This is an irrational number. Why is it irrational? Come on, guys. Think about it. The word rational and the word irrational.
It's too many numbers and you can't put it on one.
Yeah, let's talk about this. These are two English words, rational and irrational, right? So when we talk of something rational,
Yes.
it's something that makes sense to a certain degree. When we say you are irrational, it means I have to think first to actually comprehend what you're saying. Are you following? So
Yes.
irrational numbers are a lot of numbers with a lot of recurring decimals. But if you have 25,25, can that be an irrational number?
No.
It's not an irrational number. What if we have 0,625? Can that be an irrational number? It's rational, but the minute we get is that rational?
No, that's irrational.
That's irrational because you need to think long and hard for you to get to the fraction of that. So when we say we are investigating the roots, we are investigating if the numbers that we are going to get are going to be real. For instance, if we happen to have x, let's say we have x squared plus x minus 2 is equal to 0. We said here we're going to get x is equal to minus 2 or x is equal to 1, right? So if they say you must write the nature of roots of that expression, you have two solutions that are not equal. So you can say the roots are unequal, right?
Yes.
Are the roots rational?
Yes.
So you are going to say the roots are rational. Are the roots real?
Are they?
Are they real?
Yes.
So the roots are real. So basically when we do that, but there is a technique in which we are going to get. So look at this. If we happen to have x minus 2 and x plus 2 is equal to 0, we are going to get x is equal to 2 or x is equal to minus 2. What is the nature of roots of that solution?
It's rational, it's real, and it's unequal.
Unequal. So if they are non-real, mind you, if they are non-real, they cannot be rational, they cannot be equal, they cannot be whatsoever because they don't exist. So only existing roots can be investigated. Are we clear? But for us to do this, we need to use now the quadratic equation formula. Remember, the quadratic equation is given by x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. Am I right?
Yes.
Look at this. Do you see that whatever is underneath the square root will determine whether the roots are real or non-real, whether the roots are rational or irrational, or whether the roots are equal or unequal?
So if there was a 0, you'd know it's not real.
No.
It's irrational.
If where was the 0?
If when 2a, the denominator was 0, then you'd know if it's a real or a non-real number.
Exactly. If a is equal to 0, then these are non-real.
Non-real.
Yes.
Okay.
But if a is less than 0 or greater than 0, we are going to deal with real roots. But I don't want you to focus on that. That's the least of our worries when we deal with the nature of roots. But I'm glad you picked that up. Because if a is 0, we are going to have a fraction that's over 0. And anything that's over 0 does not make sense. Therefore, it does not exist. But look at this. If we happen to have minus b plus or minus, I'm writing it like that because this is the discriminant. And also whatever is here will determine the value of b squared minus 4ac will determine if the roots are real, if the roots are irrational, and if the roots are equal or unequal. Are we following? That's happening now. You're laughing alone.
Yes.
What's the joke?
I know. So we got you, sir.
So now we call this the discriminant. So the discriminant is given as a triangle like that. So in other words, we are going to say if the discriminant is b squared minus 4ac. So if this is less than 0, it means if you put anything underneath the square root which is negative, -1, -4, you are going to get an error, right?
Yes.
So in other words, for non-real roots, if the discriminant is less than 0, you are going to get non-real roots. So in addition to this one, I get we said if a was 0, we're going to get non-real roots. Again, if the discriminant is less than 0, remember, anything that is less than 0, it's negative, right? Remember the number line. If you have 0, everything on the right-hand side is greater than 0, and everything on the left-hand side is less than 0. So we are saying if what's underneath the square root is less than 0 or it's negative, we are dealing with non-real roots. Are we clear?
Yes.
Which means the opposite is true. If delta is greater or equal to 0, it is only then that we are dealing with real roots.
Yes.
The opposite is true. So for real roots, we need to have delta to be greater or equal to 0. And then for unequal roots, for equal roots, if delta is equal to 0, we're going to have equal roots. And if delta is greater than 0, we're going to have unequal roots. And again, if delta is a perfect square, if delta is a perfect square, we are going to have rational roots. So there are 5 conditions that we're going to follow to determine the roots of any solution. So to determine the nature of roots, you don't need to solve the equation. You just need to know the value of the discriminant. For instance, let's look into this one. Let's say we have x squared minus x minus 2. Right? And we need, without solving this equation, we need to identify the roots. The roots, there are 3 ways. There are 3 things that you are going to identify. Number 1, it's either the roots are real or non-real. It's either they are equal or unequal, and it's either they are rational or irrational. Are we clear? So when they say identify the roots, you are going to give me 3 ways, and you give me the conditions and why are you saying these roots are real and why are you saying these roots are non-real. Are we following?
Do we get marks for putting the reasons? So is it important?
No, it's not important. But it's important for you to figure out Why? Because for you to say the roots are real, you must have a reason for that. But it's not really important for you to put down the reason. So let's look into this.
Okay.
The value of A is 1, right?
Yes.
The value of B is -1 and the value of C is -2. So if this is the case then, so look at this. B is -1 squared, right? -4 into the A is 1 and C is -2. Am I right?
Yes.
And this is now going to be 1 plus 8. 1 plus 8, am I right? And the answer is 9. Use a calculator. It's still loading. So the discriminant is 9. Do you see that?
Mm-hmm.
So you're going to check here. The roots are real to start with.
Yes.
And then at the same time, the discriminant is not equal to 0. So if the discriminant is greater than 0, we are saying we are going to have unequal roots. So it means the roots are real and they are also unequal. And the discriminant is a perfect square. So if the discriminant is a perfect square, it means because 9 is a perfect square, it means the roots are also rational. So that's how you identify or you spot out the nature of roots. So there are 3 conditions. I'm going to explain this again. We are going to identify the discriminant will guide us. If the discriminant is less than 0, we have non-real roots. If the discriminant is greater or equal to 0, we have real roots. And if the discriminant is a perfect square, so I'm gonna ask questions randomly. So you need to know all these things. And this one goes to Ash. Close your books. Maybe close your books. I'm asking questions now. We want to identify the roots without solving the equation.
Okay.
And then for rational roots, what must be the value of the discriminant?
It must be a perfect square.
Okay, awesome. Great.
And yeah.
And then Ahisha, this one goes to you. For non-real roots, what must be the value of the discriminant?
It must be smaller than 0.
Awesome. Great. And then this one comes back to you, Ahisha. For equal roots, yes. For equal roots, what must be the values of delta or the discriminant?
Must it be equal to 0? No.
Yeah, it must be equal to 0. So now that you know these things, I want you to tell me, without solving the equation, can you please tell me, without solving the equation, tell me the nature of roots, the roots of that equation, without solving.
Without solving. So we can't even find the discriminant.
Yeah, you need to find the discriminant. For you to identify the roots, you need to find the discriminant.
So can we do that?
Yeah, you can. That's the only way. That's the only way you can find the discriminant, the nature of roots. I'm coming back. Give me 2 minutes.
what is my answer? Plus 132. 133. So this one is unequal. Unreal.
Are you done, guys?
Yes, I'm done. Ashwani has just gone to the loo quick.
What's the nature of the roots?
I said it's unequal, it's unreal, and
Remember, if it's non-real, it can be equal. Things that don't exist can be equal.
no, it's unequal.
It's unequal. Is it real?
Yes. No, it's yes.
You're not sure. Please double check.
Oh no, it's unreal. It's unreal. It's unreal. I know it's unreal. I don't know why.
It's not real. So if it's not real, why is it unequal?
No, because the discriminant is greater than 0.
I'm coming now.
Okay. No, no, no.
Hey. I'm back. Listen, guys.
Yeah.
Yeah. Sorry. Remember, things that are non-real, they don't exist. Therefore, they can't be unequal, they can't be rational or anything. Because something that do not exist does not even have the... Do you understand what I'm saying? So if it's non-real, you cannot investigate any further.
So, but this one is real.
Ahisha says it's non-real. Let me see. The discriminant.
Oh, no, it's real.
So it's real.
It's real. It's real. It's real. It's unequal, but it's real.
It's unequal, but it's real.
Yes.
So it's 45, right? So the discriminant is 45, which means it's real, it's unequal.
So it's 133. It's 133. The coefficient of A is 3.
Oh, 3. It's 133. Sorry.
Yes.
So the roots are real, they are unequal, and they are also irrational.
So, but it's not a perfect square. That's why it's irrational. Oh, I'm sorry, my bad.
Did you get that?
Irrational. Yes.
Now look at this. This is not the interesting part. It is interesting, but in an exam, they're not going to ask you a straightforward question like that. Forget it. They're going to add some spice to it. So now let's do one last one.
Okay.
Identify the nature of roots without solving that equation.
So it's still loading. Okay, so we're done.
What are the nature of roots?
They're rational, it's unequal, and it's real.
Yes, okay. It's real, unequal, and it's also rational.
Rational, yes.
It's rational because delta is a perfect square, right?
Yes.
But look at this. Let's say we have x is equal to 3 plus the square root of x minus 2. Oh, let me not say a minus 2 over p plus 1. Ooh, this is very interesting.
Yeah.
The examiner can ask you, I gotta now you know, but what determines the nature of roots? It is the denominator and also what's underneath the square root. Because what's underneath the square root is your discriminant, right?
Yes.
Every time.
Yes.
So now they can ask you a question to say, for what values of x, or for what values of a, will a solution be real?
Okay, so can we attempt it?
Please. For what values of a will x be real?
X or 8? 8.
For what values of a will x be real? You're taking forever, I'm worried.
So I don't know how to do this.
Look at this, pay attention. I thought you were gonna do it quickly. Look at this. What is our discriminant here? This is our discriminant, a minus 2.
Yes.
It's already solved. So we know that for real roots, this is how you are going to answer it. For real roots, the discriminant is greater or equal to 0. Right?
Yes.
What is our discriminant?
A minus 2.
So a minus 2 must be greater or equal to 0. Therefore, a must be greater or equal to 2. That's the answer.
I feel down. Okay.
So let's look into this. Let's say we have x is equal to 3 plus the square root of a squared minus a minus 2 all over a minus 4. And then you are asked, for what values of a will the roots be non-real?
Non-real.
For what values of a will the roots B9 real. And let's say I'm gonna give you 7 marks for this.
What? 7 marks? 9 kilo?
Do you see that we will be forced to use inequalities?
Yeah, because you have to do the I was thinking, I don't know, wait. What is happening? Escalator. Good under. What's the value? Oh. Yeah. One gives me and then no, what do you see? Yeah, So it has to be greater than 0, smaller than 0. It's 1 and 2. Minus 1 and 2. Minus 1 will give you minus 3. Yeah, it must be smaller than 0. So it's 1 and minus 1. No, minus 1 and 1. And 2. So is it minus 1 and 2?
What about minus 1 and 2?
A must be equal to minus 1 or A must be equal to 2 for the roots, for non-real, for the discriminant to be non-real root. For A to be a non-real, yeah. So
Look at this. Look at this. This is our discriminant, right?
Yes.
And this is our denominator. So we are looking for the values of A such that the solution X will be undefined.
That's 1.
So we are going to...
Why is it undefined?
No. X must be undefined. Remember, when it's undefined, it's non-real. So look at this. For us to get that, we are going to say if A minus 4 is equal to 0, to start with, because if the denominator is 0, we are going to have X, which is undefined. Right? Which means to start with, A is equal to 4. So you get 2 marks for that. But you're not yet done. Because for you to have a non-real solution or a real solution or whatsoever, it lies with the denominator and what? The discriminant. So we know that if for non-real roots, you're going to start it like this. You are going to say for non-real roots. For non-real roots, the discriminant must be less than 0. And then from there, what is our discriminant? That is our discriminant. So we are going to say A squared minus A minus 2 must be less than 0. And for that, you get a mark. And then we are going to now factorize this, which is going to be A minus 2 and A plus 1 is less than 0. Remember our critical values.
Yes.
It's going to be minus 1 and 2. So which means our solution is in between the critical values. So it means the value of A is somewhere there, which means we are going to say minus 1 is less than A and A is less than 2. So you're going to get another mark for that, you get another mark for that, and you get 2 marks for that. That's where the 7 marks was coming from.
Oh. Okay.
So
I want 2 out of 7.
So you need to know something. Look at this. You need to know for non-real roots, the discriminant is equal to 0. For real roots, the discriminant is greater than 0. For non-real roots, the discriminant is less than 0. Right?
Okay, sir.
For unequal roots, the discriminant must not be a perfect square. It must not be equal to 0. It must be greater than 0 for unequal roots. For rational roots, the discriminant. So these are the 4 things. It's the 5 things that you need to know. Because in an exam, they just want they can ask you anything. So here, the denominator plays a crucial part in you getting to the answer, as well as what's underneath the square root, or rather the discriminant. Are we following? I'm giving you another question. Get this one right for me. You look tired, guys.
No, we're fine, sir.
For what values of x will y be real?
Real.
Yes. For what values of x will y be real?
So,
Yes?
how do we know again if it's a happy or a sad graph? I forgot.
You're not supposed to forget anything we're doing.
Sorry.
If the value of a is greater than 0, it's a happy graph.
Okay. Is this the pillars? Okay, so I think I'm done. Sure. Yeah.
You're done?
Yes. Yes.
Okay, let's do it. The roots were supposed to be real, right?
Yes.
So you're going to start your solution by saying for real roots, delta must be greater or equal to 0.
Yes.
So this is going to be x squared minus 5x minus 6 is greater or equal to 0. This is going to be is greater or equal to 0. And in your thingy, you're going to get 6 and 1. And your value of x will be there and there, right?
Yes.
Which means x is less than minus 1 and x is greater than 6. Did you get that?
Yes. Yes, I did.
So you get a mark for this, you get a mark for that, a mark for that, a mark for that, and a mark for that. But we're not yet done because we had the denominator. This must real only and only if x minus 7 is greater than 0. And no, this must be real if x minus 7 is not equal to 0. Are you following? Because
Explain that again. So,
if the denominator is not equal to 0, because if the denominator is 0, we are going to have a non-real solution. But if the denominator is not equal to 0, we are going to have a real solution. So it means x is not equal to 7, and you're going to get marks for that.
Oh, I get it. Okay, I got mine. I have all the marks except for those two.
Yeah.
Yeah.
So we check everything. We check the denominator and also the discriminant when we answer such questions.
Okay.
Yeah. I wanna introduce. We're out of time. I wanna introduce simultaneous equation. I hope you will not forget the nature of roots.
No, sir. This is not so bad. Let's practice questions.
Okay, I will. I'm gonna do it now. Or later on today because I have to assist with the little one.
That's okay, sir. No problem.
Yeah. So yes, simultaneous equation, it simply means that we are going to solve two equations, or we are going to look for an equation, a solution of two unknown solutions, two or more unknown solutions at the same time. For instance, if we happen to have y is equal to x plus 1, and then we have the other equation as x squared minus 2x plus 2y is equal to y, we need to solve for x and y there. So because we're going to be solving for x and y at the same time, we might as well work with the simultaneous equations. So in this simultaneous equation, one will be linear, the other one will be quadratic. Every time. Sometimes they can put a linear or an exponential. So I know you know how to solve exponential equations. So it's going to revolve around these things every time.
Okay.
So when you have any equation, I will advise that you first start with the one with a linear pattern. For instance, let's say we have the following. let's say we have the following. This is me introducing that topic. In the question bank, there are some questions there on a simultaneous equation. Did you see them?
No.
I'm going to take this one in particular. Y plus 2 is equal to x, and y is equal to x squared minus x minus 10, and you have to solve. I'm taking it from the question bank. In the question bank, this is question 1.7h. This is 1.7h in the question bank.
Okay.
So now, if you notice, all the time, they're going to either give you an exponential equation and one linear equation. You have a linear equation and you have a quadratic equation, right?
Yes.
When you solve these equations, start by making one of these two the subject of the formula. Start working from a linear equation. Do not jump to a quadratic equation. And I'm going to take another question, which we're going to do an example of now. It's rare for them to give you exponential equations anyway. So for now, I'm just going to take two simultaneous equations. X plus y is equal to 3, and 2x squared plus 2y squared is equal to 5xy. And these are the equations that I am taking. And from the question bank, the second one is 1.7i. 1.7i. Sorry. Now, when we work with this, let's look at the first one. We have y plus 2 is equal to x, and we also have y is equal to x squared minus x minus 10. When we work with simultaneous equation like this, we need to name our equations. First thing first, we need to name our equations. We're going to have equation 1 and we're going to have equation 2. Right? So what is our equation 1? It's y plus 2 is equal to x. This is our equation 1. And then we have y is equal to x squared minus x minus 10. And this is our equation 2. So because we are going to start with a linear equation, this is our linear equation, okay?
Yes.
And our linear equation have already been solved. We know the value of x. Do you see that? So we can take the value of x, and wherever there is x, we put that in it for us to get to the solution. So guys, and I must tell you, you will never write a maths paper and they never ask you this question for a minimum of 6 marks. A minimum of 6 marks.
Wow. Okay.
Every time. You need to know you're gonna write an exam with all of this. They will give you a minimum of 5 marks to answer all these questions. Are you following? So now, so in place of x, we are going to substitute that equation. So we are going to say, we are going to substitute equation 1 in equation 2. Are you following?
Yes.
So from here, we are going to have y is equal to, so in place of x, we're going to put y plus 2 squared. minus y plus 2 minus 10. Are you following?
Yes.
And we are going to have this as y is equal to, when we expand this, we're going to have y squared plus 4y plus 4 minus y minus 2 minus 10. Are you still following?
Yes.
And then from here, we're going to have y is equal to y squared. We put like terms together, it's going to give us 3y, right? And then when we put that and that, we're going to get 2, and it's going to give us minus 8. 4 minus 2 minus 10, it's going to give us minus 8. If you notice again, you are going to have a quadratic equation because the highest degree is 2. So when we have a quadratic equation, one side must be 0. Are we clear? So if that's the case, when we transpose the y, it's going to be plus 2y squared plus 2 minus 8, right?
Sure.
Because when we transpose the y to that side, it becomes a negative, and 3y. So this is now going to be y squared plus 2y minus 8 is equal to 0. Then we are going to factorize this now. It's equal to 0. So we're going to have y plus 4 and y minus 2. And this is now going to be y is equal to minus 4 or y is equal to 2. But we're not yet done. We have solved for y, right? We're not yet done. We still have to solve for x. So we are going to see equation 1 to get x. So in that case, we're going to have x is equal to minus 4 plus 2, which is going to be minus 2, which means the coordinates will be minus 2 and minus 4, right?
Yeah.
And the next one, we are now going to take the very same one. Substitute x is equal to 2 in equation 1. So we're going to have here x is equal to 2 plus 2, which is going to be 4, which means the coordinates will be 2 and 4. And that way, you have solved for x and y simultaneously.
Okay.
Can we do another example? The second one.
Yeah.
X plus y is equal to 3, and this is our equation 1. And then we have 2x squared plus 2y squared is equal to 5xy, and this is our equation 2. Do you see that?
Yeah.
So when you work with this, you must first start with the linear equation. You take one variable and you make it the subject of the formula. Are we clear? So with that said, we are going to say we are working from equation 1. So you're going to say from equation 1, x plus y is equal to 3. Therefore, x is equal to 3 minus y. Do you see that?
Yes.
And that gives us another equation. We can name it equation 3. Then we continue and we say, substitute equation 3 in. You can't substitute it back to equation 1 because you got equation 3 by working with equation 1. Therefore, you're going to substitute it from equation what? 2.
Two.
So it means in place of x, we are going to put 3 minus y. Are you following?
Yes.
Which is going to be 2 into 3 minus y squared plus 2y squared is equal to 5 into 3 minus y into y. So from here, we are now going to get 2 into 9 minus 6y plus y squared. You will figure that one out, okay? Because we have 3 minus y into 3 minus y. So when we multiply it together, we're going to get to that. I actually recorded a video of multiplying a binomial by a binomial and also for factorization. I'm going to send it to you. And tomorrow when I get time, I'm going to do a video that will talk about exponents, the equations and everything. And I'm going to send it to you so that you can refer to it when you're studying.
Okay, sir, thank you.
So it's going to be 2y squared is equal to 5 into, when we multiply that, we are going to get 3y minus y squared. Am I right?
Yes.
And then this must multiply everything in the brackets, and it's going to be 18 minus 12y plus 2y squared plus 2y squared is equal to 15y minus 5y squared. I know when you're doing this, you might forget the signs. Make sure in simultaneous equation, you look at the signs. Intensely so.
Okay.
You look at them intensely so, because one wrong sign will mess up the whole sum. So from here, we group like terms together. We're going to get 4y squared minus 12y plus 18. When we transpose the 15y, it's going to be minus 15y, right?
Yes.
It's going to be minus 15y. And when we transpose the minus 5y squared, it's going to be plus 5y squared is equal to 0. So group terms, when we group the terms together, we're going to get 9y squared minus that, and that will give us minus 27y plus 18 is equal to 0. And all of these 9, 27, and 18 have a common factor, which is 2, right? Which is 9. So
2.
9.
9. 9, yeah.
So we are going to divide each and every expression by 9. And when we do that, we're going to remain with y squared minus 3y plus 2 is equal to 0. So we factorize that, we're going to get y minus 2 and y minus 1 is equal to 0. And y is equal to 2 or y is equal to 1. But we're not yet done. We need to substitute y is equal to 2 in equation 3. Remember equation 3? It was x is equal to 3 minus y, right?
Yes.
So this is now going to be 3 minus 2, which is going to be 1. It means our coordinates, it's going to be 1 and 2. And another one, we substitute y is equal to 1 in equation 3. And when we do that, we're going to have x is equal to 3 minus y, where we're going to get 3 minus 1, and it's equal to 2. So our coordinates will be 2 and 1. So that way, we have solved that expression simultaneously. So we're going to do it again on Tuesday.
Okay, sir.
Yeah, we're going to do it again on Thursday. And I'm going to record. So I've done a video of factorization and multiplication of binomials. And I'm going to do one for exponents.
Okay, sir. Thank you.
You're welcome. Let's meet here same time on Wednesday. So I'm giving you an extra lesson on me.
Thank you, sir. Thank you, sir.
Let's do accurate. Today is Tuesday. So let's do Thursday and Saturday this week.
Okay. Thursday and Saturday. Okay, sir.
Yeah. All right.
Thank you, sir.
See you on Thursday. Practice simultaneous equation. There are a lot of questions there on on that
Question bank.
question bank.
Okay.
So the only questions that I'm gonna send over is the nature of roads. I'm gonna use the grade 11 question papers. There will be a bunch of questions on nature of roads, and then we will do that one.
So can you send it on Teams, please?
Okay, I will. I need the tutorial, by the way.
You?
I need the tutorial on Teams.
Oh. So you can experiment, sir.
I will. I'll try to do that.
Okay, sir.
Sure.
Thank you. Thank you, sir. See you.
Bye.
Bye.
Amahelele basayarangi. Talk to Daddy. Forest my co-op. Forest my co-op. Forest my co-op. Look, sitting. Mm-mm. 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 I was like, well, what are you doing? What are you doing, man? Come. Who's Shamina? Who's Shapapa? Who's?
touchline. He seemed a little lackadaisical out there. Certainly not as creative as they normally are. Kyle Walker. Here's Sterling. Sterling! Only partially cleared, so there's still some problems for them. Bernardo Silva! Oh, a good goal. Now there are goals that are good. Well, we could be heading to a major shock here. On course to win the match, and no doubt. There's a problem for Liverpool, they are trailing. They've got the opponent's mind, they've got the ball. It's Salah now. Well, that's a good clean tackle to stop the attack. Henderson. Salah. Sergio Aguero. Over the goalkeeper to the back post. He's put his body on the line there. Bernardo Silva. Yeah, he goes for a tackle. Pressure to absorb. High up the pitch. It's with De Bruyne. Sergio Aguero. Bernardo Silva. Bernardo Silva! Keeping the ball.